go live. Hi everyone, welcome to another Wolfram Language Design Review, part of our version 14.3 series, and second one for today. This is about control and system modeling, and it is about system modeling, system model validation. And we also have some temporal logic things. Should I look at an example just to get some sense of what we're talking about?
Yeah, you can do that.
Okay.
So maybe you want to magnify it. And so often when you have a system, you worry about certain properties that need to kind of hold for it. And so very roughly or broadly speaking, they kind of fall into two camps. One is safety things, like stuff you don't want to have happening. Like if your battery temperature in an electrical vehicle goes too high, they can catch fire and it goes boom. That's not good. If the G forces on a pilot exceeds 9G for very long, that pilot is toast and things go bad. If you have a thermal runaway in a chemical reaction, that's usually bad. So those are safety examples of safety stuff. Then the other group are sort of performance-oriented things. You want your system to actually do something, like accelerate fast enough, or cool the house fast enough, or cool down the battery pack, or whatever it is that you're cooling fast enough. And so those are performance-oriented requirements. And so, those are the two biggest types of requirements. Stuff you want to have happen and stuff you want to prevent from happening.
Okay.
And so the question is, how do you formulate those kinds of things? And now there are other things that can happen when you design a system. So question is, how do you formulate that? And so to express those properties, you need sort of a language that allows you to go from a verbal characterization, like I just gave you, to a formal description that's semantically well understood, that can be used as that specification. So we have a language that you will see on that system model validate page to describe that. And that includes some new constructs called temporal logic constructs.
Saw that.
Okay. Then the other thing that also can happen is that your system isn't just one system, it's an infinite family of systems. So that means that you have uncertainty in, let's say, parameters or initial values or inputs. So then you need to sort of account for that too. Meaning that you're trying to verify basically an infinite family of systems have a certain
Well, there's
kind
a
of property.
discrete set of systems here.
Yeah. Yep.
But so how do you represent the continuous one? With an interval?
Yes. Or a distribution.
Okay. So normally this would be parameter values, blah, 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 arrow, some particular number, right?
Yeah. Right. Or the system, the model probably comes with particular values. But if we want to, when you do a system model, even though there is a particular parameter value, the description still knows that that is a parameter. So we can vary it afterwards. Do you see what I'm saying?
Yeah.
It's good
But
because
have we done that before? I mean, have we got system model plot? If I give a range of values for something, are we doing that? Have we already been doing that?
yeah, since the get-go. And we did in a previous design review, a few releases ago, we did something system model uncertainty plot,
Yes, I remember that.
right? And that shows the whole distribution of outcomes.
What
But
does it do? In the case where I give a discrete range, does it plot many curves?
Sergio, what does it do for discrete ranges?
So with uncertainty plot, it still computes the quantiles and plots the bands.
Let me see an example. So what's a minimal example of
Go to
system plot?
system model uncertainty plot.
Right.
Well, no, I want system model plot because that's what I was asking about.
No, but that does a bunch of discrete. That only does discrete stuff. It doesn't do continuous stuff.
Okay, but I'm just looking for the discrete case. Okay.
Okay. I don't know where one is, but
where's something with parameters?
Right. I guess you can go a little bit below. Maybe in the scope we have something.
Parameter specification. Where is it?
Yeah, we have a lot of.
All right, initial values here.
For instance, yeah.
Okay, so let's see. Oops. Do I want to evaluate these initialization cells?
yeah. It really doesn't have to do with this stuff. It's for the control stuff later, but it doesn't hurt.
So in this particular case, you're actually setting one value for each of the angles, but I guess you can
I
do.
can see that, but I just want to do something different from that.
Right. Yeah. Go on. That's right. The plot legend is going to look a little bit ugly because there are a lot of results, but yeah.
What's happening?
Probably running all the simulations.
Why isn't it showing that?
I think it's just yeah, it's gonna plot eventually. It's just the plot legend is gonna look is plotting the four angles.
Why is the progress monitor dead?
Oh, we don't have progress. Oh, okay. Yeah, I could enhance the progress reporting for that one. Yeah.
I'm sorry, what? What happened?
No, I have to. Yeah, that's what's happening. Yeah. No, I have to
So is
improve
that a
the progress
bug?
reporting. Yeah, sure. For the progress reporting, yes.
No, I'm sorry. I just want to clarify. Is that a bug that it didn't show the progress monitor? That it only showed it for the first instance?
Yes. Mhm.
Okay, fine.
Mhm.
Funky. Okay, so it worked though.
Mhm.
Yeah.
Okay, good. All right. So now, oh boy, oh boy. I mean, where are the other places in the system where we should be using this kind of thing? So, for example,
Let's
ND cell.
go first. Go first to system model validate, and then the reference page.
Yeah, okay. I mean, I think I get what the point is here. It's quite nice.
Okay. And so
I'm just trying to make a design that isn't just yet another random thing in some random corner. Because we've worked on what's that doing? Why am I seeing that? Dynamic content not displayed. Why am I seeing that? That's
Right. That's
probably a
from the
bug.
meta description.
Well, it's a bug, right?
Right.
it has to do with DocuTools. I don't know what it is exactly.
Okay, all right.
I think also the page is not the latest one. It doesn't look
Well,
like the
I don't know about that. So
right.
if I need to update, then you got to tell me that. You could have told me that before the meeting.
Right.
You want me to update things? Okay, I will, but it'll take a little while. Okay. So what is it you want me to look at here?
System model validate is like the central page.
Okay, well, it's going to take a while to update that, so we'll have to wait.
Okay.
Is it something we can look at while we're waiting for that?
Well, we can look at more of these bigger application examples if you like.
No, they're
On
nice.
the right.
I mean, this is nice, but I'm trying to understand.
That's trying to explain the why. Okay.
Yeah, I get
Now,
it.
in principle, all of that can be used if we build similar functions that uses desolve as a solver. It's a more, we don't have a modeling language for desolve. It's sort of a loose collection of equations.
Yes,
So
I
there's no,
understand.
right? But in principle, we could do that for both difference equations and
I
differential
understand.
equations.
But
Yeah.
I mean, okay, so would you remind me where we got to with the temporal logic project of like 4 years
But the
ago?
temporal logic didn't have actual real time. And it's a type of logic that I worked on in my former life,
I know.
and that's good, and it's primarily for proving. We're not really proving in the same sense that an experiment doesn't prove anything.
Okay, why is this taking, it's not echoing keystrokes here. Is that a bug in 14.3?
Uh,
So somebody should report that. I mean, it's probably a DocuTools failure, and it's probably related to this nonsense. It's probably some timeout.
could be. So you see the signature there, system requirement, and then you optionally can give a longer additional specifications, and we'll go into that in a sec. But the requirements is expressed. You already saw some examples of that.
Yeah.
Okay. And you can use any of our inequalities or logical constructs.
So the names of the variables, if I wanted to say, angle 1 is greater than angle 2 or something,
Mhm.
am I using string names for the variables, or how does that work?
Yeah, you're using string names and
Ugh,
yeah,
that's really disgusting.
yeah.
That's horrible.
Alternatively, you could use a quantity variable, but I guess, yeah,
But that's not easier.
yeah, exactly.
But so here, where you're talking about stall speed, I mean, that's usually string names for these variables, right?
Yeah.
Right. Mhm.
So one of the things that's a problem is that you could have an expression in terms of string names, but then you can't do solve with strings, can you? If I
Uh,
say if I say solve, quotes x squared plus quotes x plus 1 equals 0 for quotes x.
right.
Splatteroo.
Right. I mean,
Ooh,
these
need to
strings are
change
really
that.
functions of time also.
Okay. But they're kind of a hacking of things.
I mean, they're separate namespace. And
Yeah, but what's the fully qualified version of that namespace?
well, in their namespace, well, they have longer names there too, actually, because they're sort of these dot notation names of from the object. So like for instance, a resistor is electric. What is it?
Oh,
Electrical.
I've seen them. Yeah, right. But
Yeah.
okay. So there's a messy namespace, right?
Mhm.
But my question is there a fully qualified version of the name that is a symbol, with a string inside it and so on?
We haven't
Like,
done that. We've not we don't have such a thing.
okay, maybe that would be a good idea because that way, we might be able to have El Cheapo syntax that
No,
says things like
you're
string is
right. I think
greater.
and we've innovated like that with array variables, array symbols and so on. So maybe we can use a similar
Yeah,
kind of idea.
right. I mean, something like simulation variable or something like this. I don't know what the right name is.
Yeah.
System variable.
Yeah, yeah, exactly. Something like that, and that
So
would
then this
be
becomes a cheap version of that.
right. And I that's not a bad idea, okay? Or symbol, as we call them elsewhere.
Well, system symbol is not something we can use, is it?
Right. But we could
Uh,
have,
I could say system model symbol.
right, system model symbol, for instance.
Why is this? Something has gone very wrong here. There's something that is burning the CPU.
You
Something is
know,
very wrong.
could you quit and start and don't run the initialization? Because I have a bad feeling it's the control stuff. Because they're attached cells and stuff, and I don't know how well that works in the prototype build. And then next time you run something there, don't run the initialization. No. And let's see. That's just a hunch. I don't know.
Okay. Well, who knows? Okay. All right. Okay. So by the way, about array variables, do our various plotting functions support array variables at this point?
No. I mean, yes and no. Okay. But there's some project that remains to be done. So we have this thing where we introduced plotting over regions where we use vector variables, except the implementation was incomplete in the sense that you can't use symbolic array variables. You have to use a list of variables, which is not
Yeah.
the way it's supposed to be.
Yeah.
That wasn't intended. That's a mistake. And that's just
Okay. Okay. All right. Okay. So that should get fixed. But now here, I mean, something like, okay, so system model symbol of X. You know, what's interesting is that I think it is plausible, and this is what we're going to be doing for the, for things like E. Gosh, what are we calling that now? What are we calling it for the variable, the version of?
exponentially.
No, 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 no. No, when you type capital E, we're going to
Yeah.
have an autocomplete that gives you the possibility of having a wrapped E that represents, just a single symbol.
I don't know. We've talked about it, but I've never
No, no,
heard
no.
of
That we concluded that in a design review recently.
Oh, okay. Good.
I don't know who exactly is implementing it. Maybe Itai. Maybe Natalia could go chase that and check.
Sure.
I think that would be great. I hate not being able to use C or E and stuff
Well,
like
I
that.
know. I think we solved that problem. You were not in that meeting, but I think we solved it. And it's going to be you type capital E, there's going to be an autocomplete that offers you the wrapped E, if you understand what I'm saying.
Yeah, I got it. It's great. I love it.
But so we might be able to do the same kind of thing with X, having a
Yes.
wrapped X.
Mm-hmm. A string, you mean?
Well, yeah, but I mean, but you just type X,
Mm-hmm.
and we might be able to get an autocomplete that is this, and maybe we can get a display form of this that is something more attractive. See what I'm saying?
Yeah, good point. I think that would be super nice.
Fine. Well, then let's. Why don't we make sure that you know what the design is, and there was a design review
Yeah.
for God, what are we calling
And
it?
who's involved in it? I mean, I wasn't in that, I'm pretty sure.
No, I don't think you were. I mean, I would think it is. Is it Nick Riviere or is it Itai, that crowd?
Sounds like someone from front end need to be part of that. Sounds
Yes,
to me.
they were. They were.
Okay.
So, but I mean, it's supposed to be for 14.3, so Natalia should check on it. I don't know what's happened there.
Yeah, I'll check on it.
Um, um, uh, um, okay. Okay. So I'm still trying to understand where else in the system this is relevant. Okay, so we've got a whole time framework, and we don't have. I mean, I guess Nick is the person who's most involved with the time framework.
Yeah.
I kind of would like to know how this relates to that. Maybe we could see. Maybe Natalia could see if Nick Luriviere is reachable.
I think Jose was the one that was
Okay,
involved in the temporal
and
logic.
Jose.
Okay.
Well,
You want them to join?
So
yes, if possible.
I have
Okay.
a notebook report from that, which sort of kind of shows that it's not super relevant.
Okay. Can you give it to me? Send it to me or something?
Hold on, I'll have to dig it up.
Okay. I understand that was about proving, but The issue is here.
Well, yeah.
I mean, we have things like infinite future, which is already defined, right?
What is that?
Well, that's what you think it is. You know, it's
I've never used that. What is that?
well, it says now is less than infinite future, probably.
Great.
Okay, things like that.
Okay, that's an infinity for dates or
Yes,
time.
that's right. What is that thing there? Oh, that's the new icon for that.
Presumably we have negative infinite future too then?
Infinite past.
Oh, okay.
Right. So, I mean, for example, temporal always, you know, temporal until infinite future is the same as temporal always, presumably.
Yes. Well, no, I think that the other thing actually needs to happen.
Okay. Well, anyway, let's see if we can reach these folk, and then let's come back to this. I mean, now my next question is about the system model validation data, where, you know, success or failure, presumably that's a property of system model validation data. Is that correct?
Yeah.
Yes.
But you also, one important thing, we built sort of a debugging system for you to debug a system. So if you get a failure, you will get failure traces. That's very important, actually.
Okay, so for example, if I take this, if I take this example,
I can either talk or I can go and look at for the notebook.
okay, well, but if I take this example here, and I say failure plot, says key absent. I don't know. I just read this off the page for system model validation data.
I don't know if that's preserved.
It's one of those that's not saved in the notebook, probably.
Right.
Okay, but so why aren't you using that whole mechanism? Right?
I guess we could. I mean, these are not small, but we could.
Well, you need to use that mechanism because otherwise it's completely unclear what happened. And the error message there is not adequate because it should say isn't available, right? It's not something like this that looks like a structural failure. Am I making sense?
Okay.
Right.
Good
Yep.
point.
It's just like, you know, if I say, you know, audio capture or something, well, I don't know what's going to work, but, you know, we all know what those look like, right? The thing that, so you should use that. If this is a large object, you should absolutely use that. Save in notebook, blah, blah,
It's
blah.
always a large object, yeah.
How large?
Well, it can have 200 big simulations in them or something like that.
Okay, but I mean, what about what's the smallest case? So let's take this one as an example.
But yeah, I guess they're gonna need to load an external library, that aircraft library. That's so this one is not gonna work unless you have it.
I'm sorry, which library?
The aircraft library is one of the system model libraries.
Okay, but
That's
where
in
is
the
that? Where's
that,
the? How
you see
do
the
I
link?
load it?
Yeah.
It's in the library store.
Right.
Oh.
So yeah. But we can always go for the examples in the documentation page, which are
How do I get that?
free download. Yeah.
No, but I shouldn't have to do that. I should be able to click this. That should give me a piece of code that I can just run. See what I'm saying?
Okay.
Right. Just like look at the demonstrations. Look at the demonstrations project. Okay. Look at how it does it.
All right.
That's the way to do it because it has the capability to just copy something, makes a string, which then does, you know, now, I mean, if we're trying to do lead, you know, capturing information when you load the library, it might have been good to have done this in advance for me. Okay, so I can't run this basically.
Right.
So tell me on your machine how big system model simulation data is in this case.
Right. Yeah. A second.
Also, it's just mind blowing that that's a 0 point to 30 point. You know, we should be formatting numbers. And again, this is maybe something Natalia can feed to the ILD or LCC group, I guess.
Okay. By the way, Jose just joined.
Okay, great.
Yep. Hello.
Hello there. Okay, but could you just tell me how big that thing is?
Right.
No, not you, Jose. I'm sorry. That's a completely different question. That was a follow-on from a previous thing.
Oh, actually, this one is actually small because this.
How big is it?
Right, let me just run in the
But I mean,
simulation.
so what we should do here is exactly the same as we're doing. I think if I say sparse array, no, what's a good example where I can get one of those?
Sparse array is a good example.
Okay, how do I do it?
Do maybe identity matrix with a big thing. Actually,
why would this work? I don't understand why this works. Why would that give one of those things? Sparse array is tiny.
Yeah. Well, I don't know which. Maybe go to the page for sparse array. I don't know when it gets generated. Hold on.
You want
Why is this? My
size limiter?
keyboard is not echoing characters, so something else is wrong. Okay, I haven't run the initialization. Hello, hello, hello. This is obviously not connected to the correct microphone. Well, whatever. Hello, hello, hello. Well, let's just run it for a while and then just see what happens. Oh, for God's sake, this says data in file, but okay, but it could say other things, right? It's rather compressible given that it was complete silence.
You want the data size limiter? I think with
Yes.
sparse array in a range in a million, you would get it.
Sparse array range of 1 million.
Yep.
Okay, great. That's exactly what we want to do here. See what I'm saying? With the system model simulation data. Make sense? Sergio?
And
right. Yeah. Mm-hmm.
So the person that knows about that or how to do that would be Itai, I think.
I see. All right.
Okay.
I'll reach out.
Mm-hmm.
Okay, what we wanted Jose here for was all of these temporal always, temporal eventually, and so on conditions,
Mm-hmm.
and that right now are being used just for system model validate. And the question is, what other time-related functions should these be connected to?
Right. Yeah, I haven't looked very much at them. Roger showed that to me, but I haven't explored yet other possibilities.
Okay, do we have any idea what other places in the system might make use of this?
Well, beyond the logic framework.
Well, what logic framework?
I mean, in principle, I guess you could do this for a time series. Okay. So given
Yes, you could.
a time series or a whole collection of time series, like temporal data, for instance, you could build a function that tries to validate against that.
Yes, you could. So let's think about how you do that right now, okay? How do I find out in a time series whether the value ever goes beyond blah, blah, blah? What's the way you would do that right now? You'd say
Actually,
yeah.
well, you could. I mean, it's really hard right now. So there's a general limitation we have in the system that based on values rather than positions. Same with arrays and stuff. So we are building these detectors. This is kind of like an event detector. Where does it go over, or does it ever go over? And so for time series, there isn't much that goes in that direction.
I understand. It goes value based, basically. You're saying.
Yeah. So we need more things that.
Okay. So temporal always would be a good example of something where you say, I've got a time series, and now here.
Does this property always hold? Actually, that's not a bad idea, Stephen. We should probably do this. Because now I can use these kinds of specification, and it might inspire additional sort of temporal logic constructs. Because you want to express.
The design here is what? Because here we've got these variables in these system model symbols, which we'll call them that because that's what we need to build out in that area.
And at future time series, we will also have variables, courtesy of tabular, basically. So you can have within one time series, they can be vector array valued right now, but it's sort of this awkward position-based names, which is not easy to have in a formula, I think.
Well, but let's think about that because what you're doing in the case of the system model stuff is temporal always has these weird string names or system model symbol names in it.
Yeah.
But it is just a condition. It is not what it is it's validate of that and then that condition. So which is very similar to let's understand for an inequality, okay?
But it's not quite like that, Stephen, okay? These are functions of time. And what comes out of when you give an inequality, it will give you a Boolean valued function of time, which is true sometimes, false sometimes, wherever that inequality, let's say, is true.
Sorry, so if I say
if you go to any of those, let's go to temporal sustain or something like that.
I'm going to go to temporal always because well, no, actually,
well, temporal always and eventually they're the most boring because they really just output a constant, true or false. The other ones are effectively like filters. They take, Boolean valued functions of time as input and return Boolean valued functions of time.
Okay, so what's T-expr?
Temporal expr.
What does that mean?
It means it's what I defined on that system model validate page as a temporal expr.
Which is one of these system model symbols. Is that correct?
No, it could be. Go there.
Okay.
Can go to the
system model validate?
Right. So the temporal expression T-expr is a Boolean valued function of time T that been given as functions of time with inequalities, if they're, let's say, real valued, so inequality is defined, or you have other Boolean valued functions of time, and you can use logical combinations of them.
Yeah, okay, I understand. So it's a Boolean, basically. It's a Boolean condition.
Yeah, but of time. And so if you go to temporal sustain, you can see we've plotted them, right? The Boolean valued functions of time.
Yes.
So you saw that green, red thing up there?
Yeah, I did. But I mean, that was just a diagram.
Yeah, but that's more or less what those failure plots look like. Where are they? Where's a good place to look at some of them? Sergio?
Right, you can go to the first example in system model validate, for instance.
Okay. That one. Look here. Okay, so this property failed, and you can see with the failure plot exactly where it failed. And
what's the one?
One, what do you mean?
What's that one?
This is because without the one you get like a data set for all the failure configurations that you have stored in the object. The one is just for indexing the first.
Well, I understand, but if I didn't put the one there, what would I get?
A data set with all the, in this case, it's just one simulation, so it's just a data set with just the one thing.
What is the configuration thing?
So which parameter values or initial values you use to modify the model or inputs? So imagine in the uncertainty case, you're going to do several simulations.
But why is this blank here? What is that actual value right now?
Right, we didn't use any new values in this case. So it's just
null association. By the way, that somebody should report that error.
Okay.
Screencast.
So yeah, as I said, often you have uncertainty, right? There's a, and this is often how these.
What the hell is this? What is this I doing here?
This let's show example to actually this is very nice, but hold on, we need this one doesn't explain why it explains a little bit. It says what was the condition that failed. If you have a big complicated expression, you got to be able to drill down into the signals that build that thing up. And that's basically a failure. Will do that breakdown for you. But this one doesn't show it.
But so this I is something you are adding to the plot.
Yes.
Yes.
Well, that should be a more general mechanism if we're going to do that here.
Well, I mean, we encounter things for the first time here, then it can kind of spread,
Fine,
right?
but then the notion of adding an I to an output is kind of like a tooltip on a general expression, right? Yes.
I mean, it's like you can't label it all because it just becomes
No,
Yeah.
I understand that. So it's a mechanism for giving a tool-tipped label, basically.
right, basically.
And if we think that this is a good design, and I think the graphic design leaves a little bit to be desired here.
What's an example, Sergio, of something that shows the drill down?
Right. If you go to scope basic uses, then you're gonna see a little bit more.
This is a mess. I have another meeting that's colliding here. Hold on 1 second here. Shoot, I really have to go to this.
Yeah, I didn't expect us to finish this in one go. This is a lot of.
Well, okay,
No.
just a minute. I mean, okay, there's a lot of things here that are, okay, so look, this temporal, so you have a temporal expression,
Mhm.
and validate is running it against a model, basically.
Yeah.
Asking for the model. So, I
Yeah.
mean, in a sense, what we're
And
looking at is a time
so
series validate.
yeah. So the outermost thing is something that's temporal always, temporal eventually, and what they give is the time variable. The independent variable that you can use, which you need to express in your formulas.
I don't understand that. I mean, I understand that you're giving.
Look at the what's on your screen up there. Go up a little there. Okay. See temporal always. Is it always the case that R2.P.V is less than 0.55? And I'm giving T as a variable there, right? T is the scoping variable.
But I thought that this thing here is the temporal expression. That's the
Yeah.
thing that I would expect to be first.
No, but so that will, when you evaluate that if that thing of T is a function of time, then that will give something that's true and false over time. And what comes out of temporal always is always just a constant true or a constant false. It quantifies overall time, or simulation time in this case.
But okay, but so these other things like temporal until, does it have a first argument of T also?
No, only temporal always or temporal eventually. Only those are scoping constructs. The other ones are not.
Oh God, that's really confusing.
No, that was very clear on that page.
Well, maybe on the page, but it's not clear to me. And it's those
No,
functions are very similar in name, so I don't understand why this one.
What you do in other logics is that you sometimes combine the two, so sort of temporal always and until.
So I don't understand.
And so then you need two temporal until. So then you need a temporal eventually until.
Well, wait a second. If this implies this, but so what's the first argument of temporal until?
So that's a Boolean variable in the model.
Sorry, this isn't a Boolean variable.
No, I mean it's a Boolean
So
function
what
of
is
time.
that?
Okay, yeah.
What is that first argument of temporal until?
It's
That's
a temporal expression, yeah.
That's a
So
temporal
what?
expression. It's a temporal expression,
Whose value is what?
Boolean valued.
But that's not Boolean valued. This
Yes,
one
it is.
Oh, on off. This one happens. to be.
Yeah, it is.
But until this condition is true,
No,
then you're asking, is that condition true?
no.
Is that
So
right?
the first condition should be true until the second condition becomes true. Then if you go to temporal until page, you'll see the logic of it over time.
It's the one we're looking at. At
Oh,
the
it's
top.
the one we're looking at?
Yeah,
Oh,
at
yeah,
the top.
just go up in the notes. See?
Okay, listen, I'm not liking this idea that temporal until and temporal always have vastly different, vastly different structures.
I mean, we're going to have to meet again. I mean,
Yeah, but I'm
I
going to
didn't expect
suggest
you to
that,
absorb this in one. I
right.
think that's correct. So I'm not worried that it's wrong or anything like that, but we need to discuss it more.
Well, I
I understand
suspect it
that.
needs to decorate, the name needs to get somehow decorated
Okay.
or modified so that we know that one of them is a scoping construct and one of them uh, is a test, basically.
Right. So effectively a type of filter.
Right. But
You
then
know,
let's think about for the time series where presumably the exact same story. So in other words, what's happening is these are functions. I mean, in a time series,
let's say that you wanted to compare your time series against a profile of time that you are given, like
yeah.
of a function. Then you need sort of a variable there, a time variable or
No, I
something.
get it. Yeah, right.
Okay. And this
So
is exactly
validate
what's
okay, that's a nice example. I mean, validate that this time series is always less than, t squared or something.
right, something like that.
So let's figure out how we would do that, even if we're not going to do that for this version and so on. But let's figure out how we would do that
Mm-hmm.
so that we have a design that's consistent with this. I mean, and now what else, Jose, in your
So I was
world?
thinking that if we
Yeah,
have here Boolean criterions of time, we could connect to date select. Perhaps there is a way of saying I have a list of dates, select those that obey some of these criterions.
yeah, that's a reasonable idea. I mean, and that, how does it relate to all the crazy stuff about recurring events and do this recurring event until something or another happens? Does it relate to that?
It might, but we don't have yet a notation for a recurring event
I
in date
know,
object.
I know, I know. But I mean, I'm saying that this, but this, and
I think maybe one important difference here is that we have actual application examples.
yeah, I realize that. I realize that. But time series will also have application examples.
Yeah. Actually, now I'm kind of motivated to do this. This also mirrors where we're heading with time series anyways, an
Yeah.
event series. So those two.
Yeah, right. I mean, so basically the question really becomes, in the output from all the system model validate, why are we not using time series as the output?
No, I mean, the design was that we wanted to generate interpolating function because then all the workflows that come out of System Modeler are exactly the same workflows that come out of NDSolve.
Okay,
So
fine. But
we've built a whole web of workflows in the system to deal with functions.
okay, I understand. So your point is that a time series, I mean, there is a notion of a time series function, which we don't really have. A time
No, but
series for us
I'm
is,
not saying we couldn't, but we have, that's a very care, you don't just willy-nilly change the output and hope things continue to work.
no, absolutely not. But my point is this. Interpolating function has essentially an explicit variable, which is a continuous variable that you can feed as input, right?
Yeah, yeah.
Time series is like list plot, basically, is fed by discrete data
Yeah.
that is then interpolated, right?
Yeah. So we did something similar to interpolating function, right? Because you can actually give
I know,
as
an
down
intermediate
value.
value. Yeah.
Right.
Okay, but look, the point that I'm making is the missing piece is a thing you might call time series function, which is a pure function of a continuous variable t, where t, where that thing represents, and it's not a necessary object for us right now because we do just like, okay, the analogy is just like we lived for 25 years or more without units. And we didn't need to say we're plotting, x squared plus 3 with x being in units of something. It doesn't make any difference, right?
Mhm.
If we say we're plotting, t sine t, and t sine t is just some function of t. We don't have to say that t is a time. It doesn't really matter. But you could imagine something where there's a time series function, where it's time series function of t comma t sine t that represents a time series, and that might be useful if we're doing, for example, let's say we have a time series function t sine t, okay, and let's say that we want to say, is that less than time series of, I'm not sure if this is right, but something like that. In other words, it's a way of making that, or no, a better example would be this plus this, okay? Because otherwise we can't really do that. We don't have a way of adding a thing that has kind of the right, quantity type to be added to a time series as a function, so to speak. Roger, are you with me?
Yeah, no, I'm listening. There's a few problems with this. First is the curse of listability here, probably.
Well, I don't think so.
No, in this case, it wouldn't happen. Okay,
yeah.
You're right. It wouldn't. But inside a time series can be something fairly complicated.
I get it. And so the question is, does time series function to have vector variables, etc.? I think this is an interesting construct, and I think this is closely related to your system model, because I think your system model validation data is basically, tantamount
to a huge collection of time series. Yeah, it
yeah,
basically
to time
is.
series functions, not time series, but time series functions. I think.
Well,
maybe not. I'm not sure.
Well, sort of.
But I mean, the temporal always and so on is deeply related, I think, to time series function, because you can imagine once we have time series function, you could make, you could symbolically evaluate, let's say we had time series resolve, let's say, and it would be time series resolve of
so what these temporal logics sort of always do, they can think of a set of behaviors or an ensemble of behaviors or whatever you want to call them, a set of time series, if you like, and
what does that, I mean, that will be the kind of thing. It's like we've got this time series function. We want to determine, is it always less than 10? Because this is kind of analogous to where we have vector less, for example. Is the whole vector less than something or another?
But why would you need that pure function there if it's t? You could just use t.
Because it's the value. It's not the t variable. It's the value of the time series function. The value at t of the time series function is less than 10. Right? That's how do we test that time series function, which could also be just a regular time series from data, always has value less than 10.
Are you substituting that time series function in there somehow, or what's?
Yeah, but yes, but the value, the payload of the time series function.
Okay.
Okay, so let's imagine we got a time series, right? And the question is, okay, so let's say we've got population of New York since 1800. Let's hope that works. Oh, for God's freaking sake. That should work. Just saying. Time series. Okay, I want to know the answer in here. Has the population of New York always been less than 20 million?
Yeah, I got it.
Okay.
And
which is directly analogous to a lot of these things.
Yeah, it is.
So I don't know exactly how to do that, but that's what I think we have to think through.
Right.
And just for 1 second on Jose's comment about date select. Date select takes a discrete list of dates. Is that correct, or is it a continuous range of dates?
Both, a list or a date interval.
Yeah.
And then it has a criterion to select dates from that.
I see. So those are discrete examples there. But can it select a continuous range? Or does it ultimately select granular dates?
It ultimately selects granular dates.
Okay.
It's something that could be a standard. For example, in the Astro functions, I already have this situation in which sometimes it's a fixed date, or sometimes it's an interval.
By the way, in the
But
Astro case,
this feels much more like select than.
Yes, but in the Astro case, we immediately have a temporal always question. Is the orbit of Pluto always outside the orbit of Uranus?
Yes, we do. Yeah, exactly.
So what would that look like in terms of our existing Astro functionality?
Well, again, these criterions could be inserted inside find Astro event.
That's what I would think. Yeah. So in other words, it would be basically, or we need a generalization of find Astro event that is, find Astro event temporal always. I'm not sure that's quite right, but it's a cluster of things like that. And what is the spatial analog of this? Like once we have trajectories, did the plane ever go into Soviet airspace or something?
So that gets us into spatial relations.
Yes.
Okay. And we have a little bit more work to do there. And that was actually for GIS search, GIS databases, that's where a lot of like at least 2D spatial relations were developed. And we don't have nearly at all that complete collection.
Well, we have geo within, for example.
Yeah, but there's like 9 of them. Okay, so
I get it. Well, anyway, look, okay, we should wrap this meeting for right now, but I think it's clear there's a bit of generalization to do here. At least, we may introduce these things first in the system model situation, but we need to know where we're going with that for time series, Astro events, and maybe there are other things like that.
Yeah, in both cases, we've actually looked at events and the bridge to event series and vice versa. This is yet another thing because what happens, like you saw those failure events, right?
Yeah.
They actually located events exactly where that failure happens.
Okay, so we could turn them into an event series potentially.
Yes. So there are more than one connection, so to speak.
Right.
Okay.
I have got to go to this other meeting, but this is good, and let's try and pick this up as soon as we can. So, I mean, you guys should think about it a bit. Just see whether you can resolve, whatever this thing is.
So unfortunately, I think Sergio's off next week. So if we can do one tomorrow, it's hot. Otherwise, we'd do control system next week, in between.
Okay, but I mean, there's going to be some more work to do here because we got to see how this merges.
No, I'm gonna kind of work that out. So
sounds good. All right. Okay, and actually, it's also relevant for our 4 p.m. Central meeting. Some of this type of thing is going to be relevant for that.
You and me, you mean?
Well, I don't know whether it's just you and me, but maybe there are other people involved in that. Yes, but I mean this type of sort of logic and testing is going to be relevant to that there as well, I think. Anyway, I got to go. Sorry. Nice stuff. Talk to you soon.